Hello, welcome to today's video on setting up your computer for Python programming, working with the DJI Tello drone, and coding in Visual Studios. My name is Carter Ash. I'm a senior curriculum developer at iCode Corporate. I've worked on much of the Python and drone curriculum that you will be working with either in the BELTS program, the PASS program, or the summer camps. With the moving over to Windows computers, we've been getting a high volume of questions regarding how to get your computer set up. So I decided to take some time today to create a video on how to get it set up on all of these things. So in today's video, I'm going to be showing you how to install Python, how to install Visual Studios, which is the IDE, how to create a Python project in Visual Studios, how to install EasyTello, how to activate your drone so you can code it using Python, and then also cover some troubleshooting with the drones, because I know I've been also getting a lot of questions on how to work with the drones, or maybe the drone's not working because of X, Y, or Z. So we're going to cover some of these frequently asked questions on why the drone may or may not work with your code. So I hope you enjoy, and I hope this video helps everybody. So the first thing that you're going to want to do to get your drone ready to code is to get the programming language used to code the drone, which is Python. Python is seen in the Greenbelt, it's seen in the Paths program, and it's also seen in the summer camp. So just installing Python, this step is really valuable for a whole host of different curriculum. Today's video is specifically about getting set up with the drones, but this first step right here of installing Python should be done on all of your computers. So hopefully this helps not just with the drones, but with all your computers set up in Python related curriculum. The place where you install Python, you can go to www.python.org, and you'll be accessing the homepage here on the website. It's very easy. The second tab is downloads, and the website will identify what kind of computer you have. So you can see that Python is saying download for Windows. That's because the website knows that I'm on a Windows computer. So it's going to provide me with the most current Python version, which in our case is going to be fine. I like to stay on the most current version of Python just because what the students are really doing in most of the Python curriculum is on a base level of the Python programming language, which really doesn't change from one version to the next. So keeping recent with the Python versions is a pretty good procedure to take in place. With certain curriculum, if I can go on a tangent, certain curriculum has different versions of Python. Like I know in the AI and machine learning camp, there are some Python 2, and there are some projects that require Python 3.925, whatever the specific version is. But we will explain that in the curriculum. So if at any time you need a specific version of Python, the curriculum will tell you that you need that version. So for most cases, just installing the most current version of Python is fine. So what I'm going to do is I'm going to go to the homepage, go to downloads, and then the little widget right here is going to show download for Windows. I'm just going to click that, and you should see the download process take place. I'm on Firefox, so whatever browser you're using will show the downloads. Usually they're up here in the top corner. There's usually a little download icon. You can actually click it and see what you're currently downloading. So it doesn't take long to download. So what I should be able to do, might have OBS. Nope, there you go. After I download it, I'm going to open my file explorer. I'm going to go to downloads, and you'll see a .exe file. That's the file that we just downloaded, Python 3.11.5 AMD 64. So that's the correct download that we needed. I'm going to double click it, and it's going to open this this installation, this setup user interface. Here is where it's going to look a little bit different. So if you don't have Python, it's going to do install now. I already have a version of Python on my computer, so it's going to ask if I want to upgrade it. But again, these processes are still the same. I'm usually going to get an administrator request to access internal processes on the computer. Just go ahead and hit accept on that. And the process should take just a moment. Okay, so this is the setup was successful window. Yours might look a little bit different just because, like I said, you will be installing Python for the first time. I believe there's a couple check boxes. And if my memory serves me correct, the top two really don't matter. It's about asking about a little icon on your desktop, which you can choose if you wish, because then you can just double click and open a little Python window. Not really used, but the bottom uh, checkbox says add Python to path. You want to make sure that you click that add Python to path option. So this wants me to disable path link. That's okay. We'll disable that as well. The path portion of adding Python to path is really important, and that's so that all your other instances, your coding environments, will know how to access that specific version of Python because it's added to something called the path, which is a string of different file locations that the computer checks for different programs and things such as programming languages. So when we open our coding environment, if this version of Python is added to your path, your coding environment will know how to search into that file explorer. When you're choosing which version of Python to use, you should see that specific version of Python appear, which would, in my case, be 3.11.5. So we should see that in just a moment once we create a project inside of Visual Studios, which I'll make sure to mention. Great. So the next section is to install Visual Studios. Okay, so I have gone to Google or any sort of search browser, and I just typed in Visual Studios. That is the name of the coding environment, the IDE that we will be using, or we recommend to be using for the drone programming. In just a side note, in the past, we've used a lot of different coding environments like Atom and PyCharm, even the standard Python editor or REPL. And as a curriculum department, we've decided to standardize the coding environment that we use across all belts. So you should be seeing Visual Studios being used in every single belt, whether it's yellow belt in the app development or red belt with the Unreal Engine. And now in the green belt, Visual Studios is the IDE that will be used. It's very important that your location uses the same IDE that the curriculum recommends, because there are specific instructions inside the curriculum that explain where to click and how to run a file and how to set up a project and make a new file by doing these steps. And they're going to be specific to Visual Studios. So downloading Visual Studios is another key component that will help your location across all the different content that we offer at iCode. Again, this is in the general focus on getting the drone set up, but downloading Python and downloading Visual Studios will help you across all content that you offer at iCode. So I went to Google and I typed in Visual Studios, and the first one right here is Visual Studios. Visual Studios is a Microsoft product, and so this is the first option. I'm just going to click this. It brings me again to the home page. You got some good information if you want to learn about Visual Studios a little bit. You can dive into the home page, but what we're looking for is at the very top. The third option is downloads. And once this page loads, you're going to see a number of options. There's community, professional, and enterprise. We're going to be using the community, which is a, quote, lesser version of Visual Studios, and it's free. So that's the best part, is the free. But it's not really any different than professional and enterprise. Just as I was saying with the different versions of Python, what the students are going to be doing with the IDE will not require them to access the functionality of the professional or enterprise versions of Visual Studio. So community will work. We're going to hit free download. And once you click that button, it will start downloading, and it's going to take you to this, thanks for downloading page. One thing I recommend is it's got a lot of good information, such as how to install. So, it's a long list of different articles. This is how to install, which could be really helpful for you. If you're doing something in C++ or .NET or JavaScript, there's little articles on all that. We're going to be doing Python, so it might help to take a moment and watch this video or read a little bit about what you can do in terms of Python on Visual Studios. If we look at my downloads folder, go back to downloads, you can see now we have another .exe file, and that's Visual Studio setup. And what we're going to do is I'm just going to double click that, and we will start the installation process. Again, there's a little administrative warning. Visual Studio's installer, they need to set up a few things. So this could, again, take a minute for you. It's kind of a larger coding environment, so it might just take a couple minutes. So be patient with it. So after going through the installation process, which was fairly quick, I got a little notification says update available. I'm just going to go ahead and hit update, keep everything up to date, because a lot of the times updates don't necessarily mean changes to the overall environment. A lot of times it could be security updates or, bug fixes. So it's good to again, keep your coding environment to the most current version. There's actually one other part to the installation process of Visual Studios that I forgot to mention, and that is we have to install the Python development tools within Visual Studios. So I've already closed Visual Studios, but I'll show you how to do this because it's actually nice to know. If I was to go into here and type in Visual Studios, you're going to see Visual Studios 2022, which is the version we just installed. But there's also this app, Visual Studios Installer. If we open this, you'll see this is my one version of Visual Studios. You have the ability to have multiple versions and different things like that, but this is the one that you should have. And what we're going to want to do is go to Modify, and this will bring you to a UI that allows you to install all these different types of development kits. Like in the red belt, you would develop certain ones for Unreal Engine game development. In our case, we want Python. So we want to click install the Python development, and then we'll do modify. Hit modify. It's going to ask for permission. We're going to hit OK. And again, we're going to go through a short download process to get these tools installed. After the installation of the Python development kit is complete, you can go ahead and close Visual Studios installer. And now we'll go ahead and get started with the creating a Python project. So what I'm going to do for this one, I've got it right here. I'm going to choose Visual Studios 2022. It's going to open up the actual Visual Studios coding environment that we just spent time installing. And so from here, in the future, when you have projects, you should see a list of recent projects, which is nice because I usually say if you have a project that's already gone through the Python setup and the installing Easy Tello, it's really easy to just open that project and create a new Python file within it. To each his own, everybody can choose how they want to do that. That's usually how I do it. But in our case, we don't have a project. So I'm going to create new project, and it's going to give me a template for what I want. And you can see the first options with the little new icon is a Python application, classifier project, clustering project. We want the Python application. So I'm going to select it. You can see that it is highlighted. Whichever one is clicked is highlighted. And now I'm going to choose next. And I'm going to call this drone demo. And there's a location, Carter source, repos, which is fine. If we look, you have a whole option. I could choose exactly where I want it to be. I could choose my desktop or documents folder. So if a student is doing it, it might be nice to do documents and then make a folder with their name on it so they know exactly where it is. But for me, I'm just going to go standard, and the drone demo is going to be the name of my project. I'm going to hit create. Might take a moment, and there we go. Now we've got a little information tab that pops up, but you can just close that. Now we have a Python project. You can see it made me a file, dronedemo.py. So this is where we're going to be, doing our coding. And if I wanted to run, you just hit start. See a console pop up. Hello, hello, iCode. Woohoo, cool. Okay, great. Now we've got a Python program or a Python project ready to go. The next step is going to be installing the DJI Tello module, which is used to code the drone. So now that you have the Python project ready to go, you can see I ran the code up here, but next to it is our Python 3.11, which is the Python environment or the Python version of Python that we installed earlier. One thing that's really nice about Visual Studios is we can install packages and different tools to associate with our Python programming language, such as the DJI Tello module. And doing that is very easy, actually. There's a little package icon, like looks like a little present, and if you hover over it, it says manage packages for this environment. If we click on that, the tab on the right changes and we get some information. These are the two packages that we have installed for this Python environment, which is pip and setup tools, which is pretty standard. But in the search bar, we can actually run install DJI Tello. And you can see there's run command pip install DJI Tello. And if we click that, you'll see that the terminal opens up and we can install all the needed packages for the DJI Tello. Because with DJI Tello comes OpenCV and NumPy and a couple other packages. And it's pretty quickly. You can see we got successfully installed DJI Tello. So that means that I should be able to go into my coding environment and do from DJI Tello import Tello. And when we run our code, that should have no issue executing. So we got no errors, anything. That was just a simple install import statement. And if there was anything wrong with our installation, we would have got an error, but our output was nothing, which is a good sign. So DJI Tello was installed, and that means our Python project is completely set up and ready to go. Okay. So now I took just a couple seconds to write some basic code for the drone. And in the next section, I'll show you how to, or I'll speak to activating the drone, but I just want to show that everything worked and, we're good to go and start coding. So I've got this code ready to go. The procedures for running the code, right? Step one, obviously create the project. Step two, install the DJI Tello library, which we're now accessing through our code. Step three would be to write some code. And so we can see on my code, I've got a drone object being created, and then simply the drone's going to take off and then land. And the fourth thing is to get your drone, make sure your drone is charged up and ready to go. And you're going to turn the drone on. You'd press the little button on the side and you wait for the LED on the front to start flashing yellow. So I just did that and my drone is now flashing yellow. And what I'm going to do is I'm going to go down to my settings on my actual computer, and I'm going to go to my Wi-Fi. And you can see I'm actually connected to iCode Guest at the moment. But if I open the options, you can see I have this Tello Wi-Fi. This is the exact Tello Wi-Fi for the drone that's in my hand. So I'm going to choose connect, and it will take a moment. You're going to lose internet access. So you can see that I'm connected, but if I open this, it should say no internet. That's just because I'm connected directly to the drone. So I'm going to put the drone on the ground. And to run, again, there's this little button right here that says start. And as long as I'm in the right Python environment and everything, I should hit run. And maybe you're able to hear this. There we go. Okay, great. So I ran the code, and as you probably heard on the audio, the drone took off and then simply landed. And one of the cool things about the DJI Tello module when you're coding the drone is, sorry, I was picking up the drone. One of the cool things about the drone is that once the code runs, the the output terminal actually tells you what's going on with the drone. So you can see there's kind of this pairing: sending command, respond, be okay. So this is the output from this is the response information from the drone. So you can see this is for when you create the drone object. When I do takeoff, the response was okay. That means everything worked and we took off and the drone didn't have any sort of errors or anything like that. Then we sent the command land, and again, we got okay. So the drone took off, everything was good, and then we landed and everything was good. And then the program ended. So we closed that. And so yeah, now the project is completely ready to go. And this computer, if you follow these steps, should be able to code the drone using the Easy Tello module, which is the module used throughout all the drone curriculum at iCode. This should work every time, as long as the drone's set up, which again, in a moment, I'm going to talk about. So let's go ahead and switch over to talking a little bit about the drone. So one thing to know is that it would be the first issue that I would want to talk about, that I find to be pretty common with trying to get the drones to accept code, right? I think that's kind of the best way to say it is, when the drone is brand new, you have to install the Tello app on Android or iOS device so that you can connect the drone to your mobile device. And through there, that is where you will activate the drone. The drone must be activated before it can be coded. So that means you have to connect to the app. There will be a small activation window. And once you've done that, you can turn the drone on and off, and then you can connect it to your computer and start coding. If you don't do this activation process, then the drone, when you try to send the code, it won't work. So you have to actually go through the activation process before that. So that has to happen on all new drones. It only needs to happen once, but it is important to do. So I'm going to do some screen recording on my phone, and then I'm going to overlay it on this video. So it should happen now. So I've got the drone sitting next to me, which I will also try to film and add into this video, but you should see my home screen right now. And what I've just done is I've turned the drone on, and I'm waiting for the LED to flash yellow. And then I'm going to open the drop-down menu on my phone. And this is for iOS, but the same thing is true for the Android, so the same process. What I'm going to do is I'm going to go to my Wi-Fi. And you can see iCode guest, all these different things. And then the Tello, this is the same Tello Wi-Fi that I was just using on the desktop. So that's good. Mine automatically connected because I've done this before. That my drone is not new. It's been activated, as you can tell, because I just coded it. So it automatically connected. So once it's connected, I can get out of here, go back to my home screen. And what I'm going to do is I'm going to go to the Tello app. Probably going to see me in a second. Hello. Hello from the drone. I'm sitting in a supply closet. This is cool. This is the Tello app. And in your case, when you open it for the first time, a little window will appear in the middle of the screen, and it will say activate. So that's where you're going to click activate. You're going to click it right on the middle of the screen. And then once you're done, I believe you turn the drone off and turn it back on, and then it's ready to code. So I'm going to break right into some different things with this app, because I think this app is really important for getting into the troubleshooting section. So one part of the troubleshooting section is sometimes the drone will not fly for a number of reasons. And two of the troubleshooting processes are done directly on the app. So the first thing that I like to do is do the drone calibration. And so if I choose from the home screen, this little gear icon on the top left, I click that and I get a menu here. And then you choose more. Then you choose the little 3-dot icon. And there is the IMU status. Now, this button says calibrate. If I go into calibration mode, I'm going to do it quickly. Actually, I'm just going to leave. I'm not even going to click it because it's going to set my phone into a whole process, and I don't want to do that. And you guys don't need to see the whole thing. But if you click that first button, that blue button right there that says calibrate, you're going to put your drone into a calibration system where you actually have to take the propellers off and you take the prop guards off and you set the drone up in multiple different positions. And what that does is it calibrates the drone in 3D space. And so that's an issue with the drone, maybe like drifting off or not responding. Sometimes it hasn't been calibrated properly. So like if it's been put into a container and you've moved it to a location and you take it out, I usually calibrate my drones on a fairly regular basis. It's just kind of a process that I have put in place. You know, I set up the program and then I calibrate the drone. It's just what I do. It's not necessarily all the time, but it does produce good results when you make sure that your drone is calibrated. So that's one thing, is going to this calibration system. I don't really do the center of gravity one, has never had the ability to calibrate. So I don't really know why that option exists, but it's there. Though the next available option is the firmware version. So sometimes there's a firmware update, and that's the software engineers that work on the Tello internal parts will change something about how the drone should handle light or handle wind or something like that, flight stabilization, or maybe they're calibrating the sensors. You can update that firmware and it will make sure that there's no bugs or anything inside of your Tello. So updating the IMU status, which is calibrating the drone, and then updating the firmware are two important things that are good for troubleshooting. So always think about, I can connect the drone and I can calibrate it, and that will ensure that it physically flies okay. And then updating the firmware ensures that the internal computer systems in the drone are up to date and there's no new bugs or anything like that within there. Now, when we talk about the drone having trouble or not responding to code, I've found a number of things to be true with my own coding experience. And, I'm just going to kind of rattle off a number of them. And so I guess the first one would be maybe the drone drifting or not being as stable as you wish. So if you say drone.up 100, you want it to go up 100 centimeters, and then you want it to stay essentially exactly where it was. And sometimes the drone will go up 100 centimeters, and then it will kind of start drifting to the right or the left or forward or backwards or whatever direction it is. It just doesn't stay in place. And that can be really frustrating to the kids when they're trying to, obviously the challenges are making the drone precisely fly throughout the room. And, having it drift really throws the drone off, and you've got to rerun the code. So a couple things when it comes to drifting could be the propellers aren't mounted properly. So if the drone is, if it maybe had crashed, or, you just took it out for the first time in a while, the propeller, one of the propellers, or maybe multiple, but usually one propeller is somewhat loose. And when that propeller is not securely placed onto the axle of the DC motor, it doesn't spin properly. And that can cause, one propeller not to spin as fast as the others. And that could cause drift in one direction or another. Another thing could be the fact that the drone is pretty small. And so different air pressure and different gusts of wind can actually affect the drone. For the most part, it does a pretty good job handling these things. But for instance, if you are flying the drone from the floor to a table, and the table is, let's say, 100 centimeters off the ground, if you write code that says drone.up 105 and then drone.forward, when the drone goes over the table, the air pressure under the drone has completely changed, because at first it was in this wide open space, out around the table, 100 centimeters off the ground. And now it's reading that it's, 10 centimeters off the ground, which would be the tabletop. So once it goes over the tabletop, it's now technically only 10 centimeters off the ground if we flew up 110 centimeters. In this case, the drone could drift off or kind of miss its mark. What I like to do is kind of overestimate and make the drone fly much higher than that. So you can't really precisely fly the drone exactly 110 centimeters and then go forward and then land by making the drone, land or essentially go down another 10 centimeters. What you would be doing, what I usually do is if the table is at 100 centimeters, I'll make the drone go up 150 or 175 centimeters so that when it does go over the table, the difference in air pressure doesn't affect the drone as much. I found this to be a really kind of neat, workaround for getting the drone to properly be able to navigate around spaces. So I found that I think if you're trying to have the drone fly too close to different objects, most of the time it bugs out and maybe drifts off or kind of fails, or maybe even stops sending commands altogether because it reached some sort of error conclusion. And so that could be an issue that you face. So I usually like to give a wide amount of space when I'm trying to like fly under tables or over tables or through doorways and different things. Like the same thing is true if you're flying under a table. If the table, is 100 centimeters. So let's say like 95 centimeters is the bottom of the tabletop. If you want your drone to fly right under the tabletop, once the drone gets under the table and it's only 10 centimeters away from the actual tabletop itself, that difference in air pressure can really throw the drone off. So it goes both ways. If you're trying to fly on top of a table, I like to give it some space so that it goes up and then has space to navigate above the table and then land. And the same thing is true if you're going under the table. I would, instead of doing 90 centimeters, I'd probably do like 75 centimeters, something like that. Give it a, that would be about 30 centimeters or so away from the tabletop itself. That just, when you put the drone into different, like almost micro air pressure changes, the drone can really be thrown off. Another thing too, there's not a whole lot of documentation. So everything that I'm talking about here really comes from just personal experience. And one thing is that all the commands in the drone have a minimum of 20 centimeters. So potentially in the situation of flying on top of the table at 110 centimeters, you're only giving the drone a distance of 10 centimeters between the bottom of the drone and the top of the tabletop. And that distance might be the reason why it's freaking out, because the infrared sensors on the drone is reading that it's way too close to an object, or maybe it's within a distance that it really doesn't compute well. So, that's just, again, something that I've kind of thought about. The more you think about these things, the better it is to kind of navigate the troubleshooting. So that's kind of drifting. What else could drifting happen? We've talked about propellers. We've talked about air pressure. That's good. Oh, another thing that I see happen with the drone is when the drone almost like stops responding. It will do the takeoff command, but it will stop responding afterwards. And, so like, for example, if our code was drone.takeoff, then drone.counter spin clockwise 360 degrees, right? Let's make a full circle, and then we'd land. Well, the commands, the movement commands, the drone estimates its environment before it executes those commands, because it doesn't want it tries its best to not run into things and do stuff. And so and that doesn't happen with the takeoff or the land command. It just executes those commands without thinking. But what I'm saying is what I'm trying to get at is there's light. So there's a light sensor, and you actually will see it on the app. If you open the app and connect the drone, and then you put your hand over the camera, the app will say not enough ambient light. And so that's a problem. The drone needs light to function. In order for its sensors to work, it needs light, available light to be bouncing off of objects and things. And so one thing that I found is that if you're trying to code and your drone keeps taking off but not moving around or executing its other commands. Maybe it will even give you an error code through the output. That could be a lack of light. So moving your drone to a brighter area actually will affect the ability for the drone to execute the commands. It's pretty crazy, but you can actually test it yourself. I've tested it before where you can go into a dark room, try to execute some code, and it won't work. And then you take the drone into a better lit room, something that's not pitch black, and you run the code and it runs it fine. So that's actually something to think about is the space that I'm coding in too dark? Most of the time you shouldn't have that issue, but I've seen it before on multiple occasions. So something to think about, that your drone actually needs to be in light in order to work. Another thing that I would like to talk about on the drones would be the battery life. So, the equipment list recommends the drones plus an additional battery kit. That's because the drones have about a 13-minute battery life, and that 13 minutes comes from the app. So if you were to connect your drone at full battery to the mobile app and then fly it around, you would have about 13 minutes of flight time. Now, if you translate that into the programming environment, you kind of expand it a little bit more. Still, you'd have roughly the same amount of flight time, but since you're coding and then testing the drone and then turning it off and then coding it and testing it, you kind of expand that lifespan of the battery. So, but it still is a short battery life. So I usually practice turning the drone off after running it and then plugging it in. I actually connect the drone through just the micro USB on the side of the drone and plug it actually into my computer. So a lot of times I just take a USB to micro USB and I plug it into my computer. And so when I'm coding, I'm charging the drone. And then when I'm ready to fly it, I unplug it, I turn it on and I fly it. And then when I'm done, I plug it in. Now, there's kind of a balance to all of that. So, if your drone's completely charged, maybe don't have it charging 24/7 because that will degrade the lifespan of the battery itself. But if you've coded a few activities, it might be a good practice to plug the drone in. So something when you're like working with the students would be, hey guys, let's, when you're not using your drone, if, keep track of the battery life of your drone. So if your drone's kind of been used for a while, let's make sure to keep it plugged in so that we can extend the life of the project, right? Because nothing worse than your kids writing some code and then turning around and the drone is dead. So make sure that drone is charged up. That is definitely something to keep note of is charging the drone. Actually, I think that's probably about it. I mean, those are most of the common issues with the drones. We've taken the time to set the project environment up. So I would recommend, watching this video, once or twice, especially that first part of installing Python and getting Visual Studios up, and then also creating the project and installing Tello. If you've got a new location and you've got, 15 laptops, you're going to be doing this process 15 plus times, right? So, you'll pretty much commit it to memory. And the steps are very valuable to really kind of understand what's going on. So I hope that this video helped. I hope that the information on setting up the project was clear. Please feel free to reach out to me at carter-ash96@gmail.com if you have any specific questions. If you have any issues, again, go through Fran Connect and put a ticket in place. You can mark it as curriculum, and that ticket request will get sent to me, especially if it's about Pythons or drones or any of this stuff that I've covered today. And I'll do my best to reach back out and help you with whatever problem you have moving forward. So thanks for watching. I hope everybody has a good rest of the day, and I hope this video helped.